Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about the most important aspect of a database system, that is the database designing part. When we are talking about a database system, we first need to design it conceptually and then implement it to the database system. So whether we are designing it in the computational way or in a manual way, we first need to design it in the process of the conceptual, logical and physical level. So today we will discuss about it and how data models like your model will help it to design it in a conceptual as well as in a physical level. And lastly, we will see what is normalization that can help to design a database. Now, when you are talking about designing a database, the first thing we need to keep in mind that to gather as many possible information as that the universities or any enterprises or the firm that is need to get a database. First, collecting of information or this collection is very much important, and the proper sorting it down is also important. After that, we need to design it and see that all the requirements and the attributes are being given that is satisfying that the firm or the enterprise properly or not. If it is satisfying all the properties and the fundamental requirements of the basis, so it is known as a conceptual design. The conceptual design can be done by a designer who is planning for the enterprise. So first I need to specify what are the key areas of the particular enterprise, and then need to define what are the attributes that can affect the particular area. Now when they are specifying the particular area, then they need to say that what are the features that need to be added it or redundant from it so that it can be accessed and get not the data redundancy but the consistent data in a meaningful and organized way. After this conceptual designing phase is over, now this conceptual design, which is a broad overview on the particular enterprise, can be given to the physical level so that the physical implementation to the logical part. So first the physical level and then the logical level, then the conceptual level. So the conceptual level schema or the designing is done and given to the logical level. So there is a transformation that is being done in terms of the DBMS or the database management system. Till now, while we talk about the conceptual, it is very much manual and nothing to do with the database system. Now when we are talking about the logical level, it must be transformed in a way or in an environment so that the concept of that particular enterprise can be described in a relation, like in a relational model or in a year model or any of the model prescribed. So now we have transformed the data into the logical level design. So we need to design it and see for any data redundancy, inconsistency again that can be a consistency checking. So after the constraints consistency checking, we need to convert into the physical level, that is the accurate and lowest level of designing. In this physical level, we must describe all the aspects or the features of an attributes that are to be maintained throughout the database of the enterprise. Say what the universities are having a department and an instructor table. The instructor table can be get out from this university relation, but the department will be always there for a university. So it is absolutely necessary to maintain the basic relationship among the other relations on a particular relational model database. So that is the physical level, which is describing the accurate and lowest level of storage structure in an enterprise. Now that we have finished the designing of this conceptual, logical and physical level, now we need to see it in a diagrammatic way. We can choose any of the diagrams. For our convenience, we're using the ER or entity relationship diagram, and we will see it in a unified modeling language, that is a UML. So we will use UML to describe the ERD. The ERD is basically dealt with considering every attribute or a relation as an entity or an object to the enterprise. Say for an example that the instructor and department both are the entities to the enterprise university. Now while we are considering the attributes, we can say that the key features of that particular enterprise. So the entity and the relations among this, so the instructor and department has a relationship of direct member within this of the particular ERD. So now using the UML, we will see that how does it look like to have an instructor relation having a relationship of member with another entity, that is a department. Here we can see that these boxes are showing the entities, that is an instructor and department entity, and the entity has some got attributes, which is the ID, name, department name and salary, and it is a member of a department. So the relationship between the instructor and department entity is showing by this relationship of member. Now here we can see that this is called the mapping of one entity to the another. So the mapping can be of three types. One is a one-to-one entity. One-to-one mapping is known as when one entity can have only one relationship with another entity. One is to m or one is to many relationship shows that the relationship of one entity can goes from one to multi-value to another entity. Say for an example, when we are talking about an instructor, so there can be more than 2 or 3 instructor that is a member of the department same, that is physics or chemistry. So there is a 1 to m mapping in this type of relationship. And another type of mapping is the m to m, that is many to many mapping. So that many entities instances of that particular one can have a relationship with many instances of another entity. So in this way, ERD is very helpful to develop a design for the conceptual level as well as the logical level of database designing. Now we will talk about an important aspect of designing, that is a normalization. When we talk about normalization, we can say that for instance, a relationship is first built on a particular table. So first we will see that how to do that. Before going to the actual normalization part, we should describe an architecture or a design process, say for a university enterprise. When we are considering a university enterprise, we can have many of the relation. The first relation that the university has got is the department. So every university must got many of the departments in it. So the university is broadly divided in the departments. So the first one is the department. Next, in the departments, we can have the instructors. So the department is directly related with the instructors and the buildings and the budgets. So the university, the conceptual level designing, we have got the departments and the instructors. So the department is directly related with the instructors. Another thing the department has got is the students. Students are also in direct relationship with the departments that the instructors like. So the department has got students, which is also related to the department and the universities. Now when we're talking about the students, there are academic relations like the academic information of the particular student. And there are also library information of a student. And also the fees information of a student. Now that is all about the students. Now when we are coming about the instructors, we can have many of these relations like the personal information on the instructor and which department it is related to. So the university is divided on the departments. Department is related with the instructors and the students, which are two basic categories or the thumbs that can be built on an university. And also the university have the administrative part that is apart from the departments. So the university also got an administrative part. Again, the administrative part can be broadly related with the concepts of like finance departments and along with the academic departments and all. So in this way, we can broadly conceptualize a university enterprise along with all the entities and their attributes that is related to these entities. Now we will see that how can we normalize this relation, because it has got many data redundancy and inconsistency if we put it like this way. So first we will build a table and see that how the functional determinants, transparency redundancies and the dependencies among them can be redundant and avoided using a normalization. Here we can see a relation that is conceptualizing a database. So we can see here there are ID, name, salary of an instructor associated with the department name, the department buildings and the budget associated with each instructor of the particular departments. Now we can see all the IDs are unique. Obviously all the names can be unique or can be duplicated. And the salary also can be unique, can be duplicated. Now when we are coming to the department, we can see that Wu, Kim, Ravi are related with the physics department. And the physics department building is always Watson. So here is the data redundancy that is happening in this relation. The first thing, that is a data relation. So this data redundancy in this relation is having because all the departments that is having the same name can contain many of the instructors and can be put together to in this type of unnormalized relation. So we can see the first thing, that the repetition of information, and the next is the inconsistency that can happen within this relation. So suppose, say if we delete this physics department of Ravi, so all the physics department say it is obsoleted from the university. So it need to be done on this Ravi, Kim and Kurtz in 3 different positions. But if we have deleted the physics department, which is put it in another relation other than the instructor, then only deleting the physics department will done so other. Now, so this to be done is a normalization process. So normalization is being done on the process of removing all the functional dependency, the transitional dependency, multi-valued dependency and all. So to give and best at a normalized relation, we part this relation into two. One is the instructor table or the relation, another is a department relation. By doing this, so we can have the normalized result and the data redundancy can be removed. We can have inconsistent data, also our durable data. So that is all for the database design, to have it conceptually or to have it in a logical level, and the physical level is the most important one. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.